Okay, for Unit 2, we actually already added vectors. We added the x component and the y component, and we knew that the resultant vector would just be the total velocity, which would be this guy right here. Okay, so this is called our resultant vector. Right? Now, the nice thing about these examples that we did in Unit 2 is we were only working in two directions. So once we got the x component, once we got the y component, it was really easy to figure out v, and then we would use the tangent inverse feature to figure out theta. All right, for today's lesson, we're going to be looking at if we have more than two vectors. So a couple of reminders. Remember, when we set our vectors up, we are going, we have our start point to our end, and then the next vector has to connect here at the end, and then we move on up. Okay, and then the resultant vector is where you initially started to where you completely ended. Okay, so for the first example here, so we'll just go through a few things here. So the resultant vector is the sum of two more vectors. To find the resultant vector, we're going to get the x and the y component. Okay, so the thing is, we are going to now have more than three, but as long as we can get the total in the x, the total movement in the x direction, the total movement in the y direction, we're going to do the same thing where we would end up using the Pythagorean theorem to get the resultant vector. Okay, in the x direction, positive is going to be to the right, negative to the left. For the y direction, positive is up, negative is down. And when we talk about finding the sum of the vectors, we're really talking about finding the resultant of the sum of the x direction and the sum of the y direction. And again, the angle is just going to be the tangent inverse of that y over x. So this would be the opposite over the adjacent. Okay, so we have this first example here, and it says we want to find the magnitude and the direction of the resultant vector of a plus b plus c. So we're adding three vectors together here. So the first vector a is 20 newtons. So you guys don't know this unit yet. This is a force unit, but this is the direction we're going. So this is 20 newtons at 30 degrees west of north. And then we have for B, 10 newtons south. And then for C, 15 newtons. And then I left off the angle measure, so that's going to be 20 degrees south of east. Okay, so it's really helpful to set up a table, and I'm going to walk you through how to use this table. And it's also helpful to draw your vectors. What I want to do first before I get into the algebra piece of this, I want you guys to take a look at what it looks like when we add a plus b plus c. So coming back to this, I have, I pre-drew, so this is my A, and this is 30 degrees in this direction, all right, so 30 degrees west of the north. And then I have my 10 newtons south. And then I have my, what was the last one there? It was 15 newtons south of east. Okay. So let me, so I drew these on an axis so I would have a reference for the angle. But remember, vectors can go everywhere. So what I'm going to do is I'm going to erase my axis. And then I have my three vectors, and I'm going to move them around because what's going to happen is I need to make sure I go from tail to tip on all of them. So let's say we started in the green direction. Okay, so I'm going to go from green to blue to pink. So if we start from the green, then my blue has to start at the end of the green there. And then my pink has to go to the end of the blue. So then what happens, and depending, I know it's kind of hard to get these perfect, but my resultant vector then should look like this. Oop. All right, so here's my resultant vector in the purple. All right, so you're like, well, how do I know which order to go in? Because I went green to blue to pink. So let me circle this guy here, get this out of the way. All right, so this is my resultant vector. Remember, vectors can be moved anywhere. So let's say instead of starting with green, let's say I started with blue. So let's go blue to, we'll say blue to green. So let me move this. So blue first. So I move blue, then I move green, And then I'm going to move pink. And then, since this was my start, if I put this up here, notice it does not matter the order that you put this in. You're going to get the same resultant vector. So just to verify one more time, if I started with pink, so let's start with pink, and then let's go pink to green. Okay, so my pink ends here, so my green's gonna go here. And then to blue. Okay, so I put this over here, and sure enough, notice, same resultant vector. So the order that you move your vectors around does not matter. It's just you have to start where you finish. So whatever motion you're doing, whatever your motion you're doing. So here I started, I ended here. My next direction has to start here, and wherever that ends, the next vector has to go. And then my resultant vector is going to go from the start to the finish. Okay, so geometrically moving around, this is what my resultant vector would look like. All right, now we're going to want to be able to find the magnitude and find the direction. So while visually this is a nice kind of understanding of what is actually happening and what that resultant vector means, what we're going to do is we need to figure out, okay, I have these three vectors. How much are they going in the x direction total? If I added up all the x directions, so I can see that for this blue one, the blue one here is going x this far, okay? And the green is going in the x direction that far. And then the pink isn't even moving in the x direction. So what I'm doing is I'm trying to add up the sum of all the components so that I can get more of a two-vector situation where I can easily then find the resultant by the Pythagorean theorem and then use tangent inverse to find theta. So that's what we're going to do here. So